Hello friends and welcome back. So in this session we are going to cover the HCL, which is Hashicorp configuration language. So what we have learned so far about the Terraform is that it is a completely a code base. That means whatever the resources that we want to configure, we create the different code files, which is also called the configuration files, right? So the very important thing here to understand how we create the different configuration files, how we define the different parameters, what are the standard syntax that we use in the different configuration files, how we provide the different inputs to the configuration files, right? Because so far we have learned about the workflows, how we execute the workflows, what are the different steps. First we do the Terraform initialize, then we validate, then we plan, then we apply, right? But for this particular workflow, when we execute, we need to create our project first. And project is which is a set of configuration files. Our configuration file includes whatever the resources that you would like to configure. Okay, so now we are going to start with the configuration files from this session, okay, which will help you to understand deeply, okay, like how we create the different configuration files, which we call when we initiate the workflow. Okay, so very first thing, what is Hashicorp? Okay, so Hashicorp is an American-based company, okay, that developed a tool used for modern infrastructure automation and cloud operations. So now, as you can say, this is in now Hashicorp is an IBM company because IBM has officially completed its acquisition in around February 2025. So this company was completely involved in development of some tools which is used for the complete end-to-end automation of the infrastructure and cloud operations. Okay, and HashiCorp configuration language HCL. It is an open source language that is developed by this HashiCorp organization. Okay, for the infrastructure automation and cloud operations. Okay, so Terraform is one of the tools that they have developed for infrastructure as a code, but apart from that, they have a few more other softwares are also there, like the Vault is there for secret management, Console is there for service networking, Nomad is there for workload orchestration, Packer is there where you want to create the machine creation. So there are multiple tools are available from the HashiCorp. Okay, so what we are going to cover here, we are going to cover one of the tools that has been developed by the HashiCorp is Terraform. So Terraform use the HashiCorp configuration language. Okay, so the whatever the code or the configurations that we define for creation of the different resources, that particular files follow the HCL configuration language format. Okay, this is just like a very simple language. Just we have a different programming languages. Okay, we use for development of the code. So similarly, we have this HCL language, which is used to define the different blocks of the configurations, which we call with the help of Terraform CLI for the configuration of our resources. Now, what are Terraform configuration files? So, Terraform use configuration files written in HashiCorp configuration language format to define the infrastructure. Okay, and these files describe the infrastructure resources, cloud providers, variable and output, configuration settings. So that means whenever we define the different configuration file, we have to define the multiple resources in the file, right? For example, if you are going to create the resources in the AWS cloud, okay, so you may need to create the VPC, then you may need to create the subnet. Okay, then you create the EC2 machines, you can create the storage, you can create the load balancer, right? So there, that means we can create the multiple kind of a resources, and then we have a different cloud service providers like AWS, Google, Azure, IBM, right, Oracle. And then when we create the different resources, so we need to provide a lot of variables and output to the configuration file, right? So we create the programming files or the configurations in the object oriented programming way, where we define the code once and then we called it for the different places, just providing the different variable according to the requirement, right? And along with that, we do the multiple configuration settings. That means HCL is a language. Okay, we use the format of HCL language to describe our file, or you can say to describe or to create the different configuration file to create the different kind set of resources in the cloud environments. Now, what is HashiCorp configuration language? So it is a human readable configuration language. It's a very simple, straightforward language. You need to understand the blocks, how we define the blocks, what are the standard syntax. And once you have a clarity on that, you can easily understand and work on the Terraform with the help of configuration files. Okay, so it is designed to be easy for human to read and write. So it has been designed in a way so that anyone can understand it easily. There is no requirement of that you should have some good understanding of some programming languages. Also, there is no requirement such requirement. So you can easily read and understand this HCL language and can adopt it easily. Structured for machine to process and suitable for infrastructure configuration. So it's a very straightforward and simple language, which is a very structured language. Okay, so we define the content in the configuration file in a structured manner with a predefined blocks, okay, which you can learn. Okay, and then define your configurations or your infrastructure in the different configuration files. So in Terraform, HCL is used to describe cloud resources, infrastructure settings, variable and output. So as we have discussed in the previous slide, okay, you can create the different resources, you can display the different infrastructure settings, so that you can pass the different variables to your codes, you can get the output of the execution. So a lot of activities that we can perform with the help of this configuration files, and we are going to understand it in detail in the next subsequent sessions. Okay, so Terraform configuration files typically use the .tf extension. So this we have learned in the previous session as well. Then when we create the Terraform files, okay, so we give the name for Terraform file as .tf. So far we have seen we have created a file main.tf, right? So similarly, we create a different configuration file for different configurations, set of blocks, and then we give the name as .tf. Okay, and along with that we have a one more file which is called .tf where. Okay, and in this that .tf where file we define the different variables that we pass to the configuration files. Okay, to make our code dynamic, so that we can define the code only at once and then we can utilize it at the multiple places. Okay, so now we'll understand how we defined the structure of Terraform configuration file. Okay, so some understanding we have got in the previous sessions where I have shown to you how to create a simple EC2 machine, and before that we have seen that we have initialized a Terraform block, right? So it is the same structure that we have seen so far, but now we'll get a deep understanding of that so that you can able to do the other configurations as well. Okay, so now the structure of Terraform. So the general structure of Terraform syntax is very straightforward. You can see here in this structure: block type, resource name, then your curly bracket, and then argument equal to value. So this is the very generic format whenever we define the different blocks in the Terraform. So you have to understand this block properly. What is the meaning of block type here? What is the meaning of resource type? What is the meaning of resource name? And then argument and values. And this block has to be under the curly brackets. Right. So now, as I was saying to you that this code we have seen earlier as well, right, in the previous session. So there initially we have defined this when we initialize the Terraform, right? So there we have given a block with the name of Terraform, and inside Terraform we have defined required providers AWS, and then we have given the source and what is the version, right? Similarly, when we created the one of the machine EC2 machine, and in that there we have seen that we have defined the provider, and in the provider we have defined the region, in which region we want to create the particular resources like the virtual machine. And then we defined a resource called AWS underscore instance, right, with the name of web. And then we have defined the web AMI and then instance type, right? So this we have seen earlier as well. So you can see here, these are the different blocks. This is the first block, this is the second block, and this is the third block. So we have a three blocks are defined here. The first block name is Terraform, and this is to define which cloud service provider you are going to use, so that it will download the corresponding connector or the plugin. Then we defined a new block for the provider. Okay. And third, we have defined a resource. And inside the resource, we define the AMI information. So now you can see here block type. So you can see here the first block type is Terraform. Second block type is provider. Third block type is resources. Okay, so we define the different block types. So there is a set of blocks, predefined set of blocks, okay, that we use according to the requirement. For example, if you are going to initialize the Terraform, we have to use a Terraform block. If you are going to use any of the providers, then you have to use a provider block. If you are going to define or create the different resources, you have to use the resource block. So this is the block type, which is a predefined element. Then we have a resource type. So if you see here resource type, in this block we have a required underscore providers. Here we have given AWS. Here we have given AWS underscore instance. So these are also the predefined resource type that we have to use based on what exactly we are going to perform or what action we are going to perform. Okay, so this is called the resource type. And then resource name. So resource name we can give any according to our requirement. Right. So let me show you here. So you can see here the resource we have defined AWS instances, right, in this block to create the AWS machine. So here we have given the name web. So this is the name, or you can say is the identifier for the Terraform that we can define according to our choice. Then curly braces, starting and ending. You can see every block is started with the curly braces, right? And then argument equal to value. So everywhere you can see that we have given some argument and then corresponding values. Right? Region equal to region name, AMI equal to AMI ID, instance type equal to t2.small. So this is the argument equal to value. So this is the main block, or you can say the main syntax, okay, that we use to define each and every block whenever we define the different set of configurations. Okay, and block you have to understand the different blocks types that I will explain to you. What are the different block types that we use and what is the purpose of each. Okay, so now you can see here, this is one of the simple example what we have discussed here only. So I have taken one of the block to create the EC2 machine. Okay, so for creating the EC2 machine or the resources, we use the block resource. Okay, this is the block type that we have resource. Resource type we have used AWS underscore instance because we are going to work with the AWS instance. Resource name we have given according to our requirement web. Then we have defined the AMI ID and the instance type. This is one of the block to create the EC2 machine. So here what we have resource first. Then we have AWS instance. Then we have given the name for the resource. Then we have given the AMI instance type. So these are the key value pairs, right? This is a key. This is the corresponding values. AMI is the key. AMI ID is the value. Instance underscore type is the key. T2.micro is the value. So we have this key field and then we have corresponding value fields. Right. So this is the building block of your Terraform that you should understand. And if you have understanding of this, you can easily work on the Terraform when we have to define the different code files. Very first, block type. Second, resource type. Third, resource name. Fourth, argument, and then argument value. So here, resource name you can define according to your choice. This is the provider specific, right? Because here you can say t2.micro is the instance type from the AWS. This is the AMI ID. So this you can get from the cloud service provider. And apart from that, your block type resource, your resource type name, and the argument. These are the some generic or predefined values that you have to understand. Okay, so now what we will do, we will quickly cover one by one each and every section like block type, resource name, argument and argument values. So first we are going to cover block type. So far what we have seen the resource type, block type as resource, right? Where we have defined one of the AWS instance, EC2 machine or EC2 virtual machine in the AWS cloud. So what I said to you, this resource type is a fix. This block, or you can say this block where we define the resource, it has a predefined values. Okay, that means we have to understand what are the predefined values, what is the purpose of each and every predefined values, and how we utilize that one, right? So what I am covering in this particular session, I am going to give the overview of what are the predefined block types apart from the resources and how to utilize them, that I will explain one by one with the executions in the subsequent sessions. Right. So in this code, the very first thing is your block type. So far we have seen resource block type. Okay. So resource block type is a built-in Terraform block type. So apart from that, as I said, we have a multiple inbuilt block types. So these are documented in the Terraform language documentation. Okay. So these resource type you can see in the Terraform documentation as well. Right. So far we have seen resources. Apart from that, we have seen provider. Right. Let me go back and show you. So here you can see we have seen the provider, we have seen the resources, and we have seen the Terraform as well, right? In these three different blocks. So now here we have seen resources, provider. Now apart from that, we have a block type variable, output, data, module, locals, and Terraform. So this Terraform, resource, and provider block type we have already seen with few examples. And then I will explain you all these modules or all these blocks as well, what is the purpose of each and every block and how we define the different configurations using these particular blocks, right? So this is the first section, which is the block type. Now let us go to the second section, which is the resource type. Okay, so this is clear now. Now we are on the here resource type, second section. Right. So far we have seen AWS underscore instance. So similarly, we have a different resource type. Okay, and that resource type you can check in the particular cloud service providers documentation. So we are going with the AWS. So these resource type we can get from the provider documentation, like from the AWS, right? Because this is specific to the AWS, or we can say a cloud service specific. Right, because here we are going to create the resource. So for example, if you are going to create the EC2 machine, what we have seen so far, so we have to give AWS underscore instance. Right. Similarly, if you want to create the VPC in the AWS, so we have to give the resource type AWS underscore VPC. If you want to create the subnet, then you have to give AWS underscore subnet. You are going to create some security groups, you have to give AWS underscore security underscore group. You want to create some S3 bucket in the storage in the AWS, then you have to give AWS underscore S3 underscore bucket. Right. So these are called the resource type. So block type, the first block type, it is fixed. This we have seen in the previous session. So that resource type, you can get information from the Hashicorp or HCL documentation. For this second, which is a resource type, you have to go to the provider specific documentation to understand what are the different provider specific resource type, and you have to specify what, depend on what are the resources that you are going to configure. Right. So first is clear, second is clear. Now let's go to the third one. So what is third one? I said this is the resource name. So this is not specific user defined. You can create any according to your requirement. So here you can see in this code what we have seen so far, we are creating an EC2 machine. So for EC2 machine, we have taken the block as resource. Resource type, we have taken AWS underscore instance. Both are predefined values. And name we have given web. Right. So this is the identifier for the Terraform, because Terraform creates a state file whenever you apply the configuration and create the different resources in the cloud. So every resources that has been configured in the cloud, it is maintained by the Terraform in the state file. Right. So how the Terraform is going to identify each and every resources with this particular identifier. Right. So here we have created AWS instance with the identifier web. So how Terraform will identify this particular virtual machine in the Terraform state file with the name of AWS underscore instance, this one, and then dot web. So by this naming convention, Terraform is going to identify this particular virtual machine and will maintain in the state file. Okay, so here web is a resource name. This is a user defined. You can define any name for this one. It is just a local name inside the Terraform configurations because it is maintained inside the Terraform configuration file. Okay, so these are few examples. Like if you are going to create the instance, you can give any name. For example, if you are creating a web server virtual machine, you can give the name web. You are going to create one virtual machine for database, so you can give the name as database. You are going to create some machine for application server, so you can give app underscore server. These are the few standards that we follow. Okay, otherwise you can define any name or any tag according to your requirement, and this tag or this particular resource name is going to be referenced by the Terraform internally, which is going to be maintained in the Terraform state file. Okay. So next one after first three is the argument and argument value. Okay, this is very straightforward. So what we have seen so far, how we define the block. This is the block, your block type. This is your resource type. This is the name, custom name, whatever you can give. Then we have the braces, and inside the braces we define the different parameters as key equal to value, argument and argument value. But I'm saying it as a key and value. So argument value. So here we have defined two arguments. The one argument as an AMI ID, second argument as an instance type t2.micro. Right. So here AMI is the argument and AMI123 is the argument value. Okay, so this is wrong. AMI is your argument, and instance type is your, again instance type is your argument. Okay, and your AMI3 and this t2.micro are the argument values. Right, key value, argument and argument type. So AMI instance type arguments are built in Terraform argument type. So these are the again built in type. So that means arguments that we are passing here, these are the pre-built one. Okay, you cannot use according to your choice. If you are going to create a AWS machine and we have to specify AMI ID, so you have to use the tag AMI. Okay, if you have to define an instance type, whatever kind of an instance you are going to create, for that you have to use the instance underscore type. So these arguments again are predefined values, okay, which you can see in the AWS documentation. Okay, and argument values is again depend on what kind of a resources you are going to configure, right? That means if you are going to configure an EC2 machine and you have given the AMI, so this AMI, every AMI has a fixed AMI name that you can check from the cloud console, which I have shown to you in the one of the previous session as well, right? And again in AWS documentation you can see the AWS has different instance type based on the number of CPU, core, RAM, etc. So these value you can take from the AWS documentation. So in a nutshell, the argument and argument value, both you can check from the AWS documentation because we are following the AWS. If you are working for some different cloud service providers like Google, Azure, so you have to look for the corresponding cloud service provider documentation. Okay, so similar to AMI and instance type which we have seen. Okay, there are multiple more arguments are there which we use for the configuration of different type of resources, right? So AMI instance type we have seen. So similarly, if you are going to create the subnet, you have to use a subnet underscore ID, okay, and you are going to create a key, okay, key that we use for the login to the machines. So you can specify the key underscore name. If you want to specify any tag, you have to use the tags as an argument. So these are the fixed values that we pass as an argument, right? And values are again the fixed that you have to check from the AWS documentation, right? So this is the building block of your Terraform HCL, okay, and this format is used across all the configuration files whenever we define different type of configurations. Okay, now how values are stored in the state file? So what we have been so far, whatever the resources that we create, right, that resources information is stored in the Terraform state files. Now how the values are stored, and very straightforward and very easy. Suppose that here we are creating a resource AWS underscore subnet. Okay, so what we are creating here, we are creating a subnet here. Okay, so when we are creating a subnet, we need to provide some information. What will the VPC ID? Because every subnet is created inside the VPC, right? So what we have discussed so far initially in the introduction to AWS. So whenever we create our account in AWS, so very first thing we create the VPC, virtual private cloud. So this is our private cloud because in the cloud you have multiple customers. So VPC segregate or isolate each and every customer from each other. So once VPC is created, then we create the other resources. And very first thing that we configure is the subnet, right? So we can have a public subnet, we can have a private subnet. So when we create the subnet, we need to provide the VPC. And along with that VPC, we have to provide a CIDR block. So CIDR block is a range of IP addresses, right? For example, if we are expecting to create 50 virtual machines inside this particular subnet, so we have to define what all are the IP addresses that can be assigned to all the virtual machines, which is going to be part of this subnet. So for that, we define the CIDR block. Okay, so that means here we are creating a resource which is your subnet, and we have given the required input VPC ID and the CIDR block. Based on that, a subnet will get created. So once suppose this particular section is executed by the Terraform, okay, and after that, once it is created, the Terraform is going to store the current state of this subnet in the state file. So what are the informations will be returned by the AWS once your subnet is created, so that the corresponding information will be stored in the Terraform store file, state file. Okay, so that means once your subnet is created, your AWS will return the information ID. So this ID will be a unique ID that will be assigned to your subnet once created. Okay, and there would be a corresponding ARN for each and every resource in the cloud. We have a ARN. Okay, the ARN will be returned, VPC ID will be returned, CIDR block of subnet will be returned, and in which availability zone this has been created, it will be returned. So these are the values will be returned by the AWS once the resource is created by the Terraform, and all these value is going to be stored in the state file, right? So we have a .tf state file, right? This we have seen earlier. So all this information is going to be stored in a state file, and by this state file, your Terraform can understand what all are the resources that I have created in the cloud, what is the corresponding ID, what is the corresponding ARN, what is the corresponding VPC ID, CIDR block, availability zone. So by this way, Terraform track each and every resource which has been created using the Terraform configuration. So this is a link of documentation, okay, because we are going to work on the AWS. So you can go through this link. Okay, here you will see all the different resource type that we use in the in your configuration files when we define the resources. Okay, so here you will see the resources, providers, modules, state and backend, data sources, variable, local output function. So there we have a standard values when we create the different configuration files. So similarly, you will have a documentation from each and every cloud service provider. Okay, when you are going to work with the Terraform for the configuration of the resources. Now, few more important things. So when we define the different configurations in the different configuration flags in terms of the blocks, okay. So we define the code in a way that so that we can reutilize that. Okay, instead of defining same code again and again, what we do, we follow the object oriented programming approach. Define once and use multiple times. Okay, so for that we have the expressions. So expressions are used to calculate values or references other element inside a Terraform configuration. That means whenever we are designing the different kind of codes in the Terraform, okay, so there are multiple ways to provide the dynamic value so that our code can be utilized at the multiple places. Okay, so when we reutilize our particular code with the help of expressions, okay, so it makes your code dynamic, reusable, and flexible. Right. So how we call these different expressions? So there I will explain you two very simple ways that we are going to use at the multiple places. Okay, whenever we are going to reference some pre-existing configurations. Okay. So now this is one of the example that you can see here, and it's a very simple and straightforward example. So here we have defined what variable. Okay. So variable we have defined instance type. Okay, and in this variable we have defined a default value t2.micro. That means if we are going to create the virtual machines, okay, so there would be a multiple places where we need to create the virtual machines for different environments. Maybe in the same environment we are going to create multiple similar kind of a machine like t2.micro. Maybe we are going to create development, non-production, production, development, and other some environment where we are going to create the machine. So we can define a variable where we can store some default value for the instance type. Okay, and then wherever we are writing the code to create the particular instance. Okay, so instead of writing this value again and again, what we can do, we can call this particular variable inside the particular instance type. Right, this is the resource type. So how we call it? Var dot instance type. So here we have defined variable with the name instance type. Right, so how we are calling this variable? Var dot instance type. So variable now converted to var, then dot, and instance type is converted to instance type. So by this way we can call a expression using a particular variable. Now apart from that we have some more ways where I explained you. We create a .pf var file, right, variable file, so where we store the multiple values that we can provide as an input. Okay, so this is one of the way, and then I will explain you this as well in the subsequent sessions. Now apart from that, we can express or we can reference a resource with the another resource in the same set of configurations. What does it mean? Again, very simple. So this we have seen so far, okay, that we are creating a subnet. So when we create a subnet, what are the values that is returned and is stored in your Terraform state file? The corresponding ID, ARN, VPC ID, CIDR block, and availability zones, right? So once your subnet is created, this we have discussed in the previous slide some time back, right? So once the subnet is created, these are the values that will be returned by your AWS and which is going to store in the state file of your Terraform, right? Because your state file contain all the information about the resources that has been created by or maybe deleted by or updated by your Terraform. Okay, so now here if you see we have created one subnet, right? And after creation of the subnet, some new values are generated and stored like the ID. So each and every resource has a corresponding ID. So here we have specified the VPC ID and the CIDR blocks to create the subnet, right? So ID is a new value that has been returned by your AWS along with the ARN and then availability zone, right? Now suppose that at some places in your code you want to get the ID of the subnet that has been created dynamically, right? What I'm saying, in the same code I am creating a subnet. After the subnet is created, I may want to create a virtual machine inside this subnet, right? So this subnet I am creating dynamically. So that means I need to get the ID of this subnet dynamically. Once the subnet is created, after that only I can get the subnet ID. And once I get the subnet ID, then I can create the virtual machine inside this particular subnet ID. Right. So in that case, once we have created our subnet, how we can call the particular ID from this particular block when the subnet is created? Very simple. We can call it like this one. This is AWS underscore subnet, AWS underscore subnet. dot main. This is the main, this is the name of resource, and then dot ID. And this is the ID that has been returned by your AWS when the resource is created. Okay, so it is not clear here. So let me write it AWS underscore subnet. This AWS underscore subnet, this is the value dot main dot main. This is the name of resource we have given here, and this is the ID that has been returned by your AWS once the subnet was created. So dot ID. Right. So by this way, I can fetch the value that has been dynamically created during the execution. So many times it has happened that we need the dynamic information. One example I have given to you. Once the subnet is created, okay, I am going to create a virtual machine. And for virtual machine, I need a subnet ID. So this subnet is creating dynamically during the execution. So once this is created, this ID will be returned back. So I can fetch this ID with the help of this particular way, and I can create the virtual machine inside this particular subnet, which is created dynamically, right? So apart from that, if you would like to sorry, define the comments inside a particular code file, so you can use the hash or a double forward slash. And if you want to specify the code in a multiple line, then you can use this one forward slash and then star, and at the last star and then forward slash. These are the specifications you can use to define the comments. Right. So what are the key takeaway what we have learned? How we define the blocks in the Terraform code file. So this is a very generic format that we have discussed so far for defining the code file. So now hope it is clear to you how to define the blocks. What are the different predefined block or resource type that you have to understand from the Terraform documentation, from the cloud service provider documentation. What are the different kind of inputs that we can provide, right? So hope everything is clear to you. So now we'll move forward with each and every block in detailed way. Okay, so that you will get a complete end-to understanding before we jump into the execution.